In our last video, we set up the storage class based on NFS. So what we did, this is our OpenShift cluster setup. And on this load balancer, I set up the NFS. And by using this interface, 10, 10, 10, 1, all the cluster nodes can access the NFS storage. And storage class, the storage class provisioner I deployed as Helm chart, and that is up and running. So just to see a quick overview, this is the dashboard of OpenShift. I logged in with kubeadmin, and in the on the load balancer, first of all I need to check who am I. uh, so I am logged in as kubeadmin. So OC get storage class is configured, and OC get projects and OC get projects, or either you can use OC projects. Both will show you the same output. OC project command will show you which project right now you are using. So right now you are connected with this project. So you can jump into any project because you are admin. So this NFS storage class we created, and star mean you are right now using this. Okay, now OC get all hyphen n. I am right now in the same project, so I can see this is up and running. OC get PV persistent volume we created, and we create a persistent volume claim in the same namespace, in the same project, and it is working fine. Now we have to connect persistent volume claim storage with the image registry. So for this purpose, I will use this documentation, OpenShift documentation. So here, this is the OpenShift documentation, and this documentation is about the configuring the registry for bare metal. Whenever you are going to set up on-prem or your own infrastructure-based OpenShift installation, so you must have to follow this documentation. So for I am using variant 4.15, or you can select your own variant here. So I'm selecting 4.16 or 15, both are same. There is no difference for the registry based configuration. So you can read all these information, like you can see the uh, uh, what type of configuration you need to do. So changing the image registry management state. So first of all, image registry storage configuration, there is a special uh, operator. OC projects. Just I will grab registry. So OpenShift image registry is the project or namespace that contains all the stuff related to image registry. So OC get all hyphen n, and OC get all hyphen n. So these are all the resources by default created with the cluster, but these are not the complete resources, because image registry container is not running because it is by default not configured. And so what we have to, so configuring the registry storage for bare metal and other manual installations. So you must have to log in with cluster admin. So right now I am logged in with kubeadmin, and 100 GB at least storage you have to provision for your image registry. So to configure your registry to use storage, change the spec storage PVC in the this resource. So I will show you, but here verify that you do not have a registry pod. So first of all, I need to run this command. Maybe this image registry pod in this namespace is running, but with this label there is no pod so far. So its mean image registry is not running. So here you can see no resource found. Okay, if you do not have a registry pod in your output, you do not need to continue with this procedure. If mean is your registry is already running, it's mean it's configured. You don't need to follow this the next process. So far we don't have, so we will follow this next step. So now this is the configuration of OpenShift cluster. So we need to edit this, and we have to define here the storage parameter. Leave the claim blank to allow the automatic creation of the image registry storage. So I will not leave this blank because we have to provide our own persistent volume claim. So this is the config, and here under the specs, it is the here you can see the storage is curly bracket mean the default value. There is nothing. So here we have to add PVC and then claim and then name of the claim. Name of the claim I can say I will create with the same name. Uh, I will create with this name image registry PVC. Then this it will automatically use this storage class to make the storage persistent. Okay, just I save this, and here you can see edit it. If you made any mistake, it will give you error here. Now I must have to I will provision this storage persistent volume claim now, but there are some other settings we must have to do. Check the operator status. So there is an operator, image registry operator, that is running, that is responsible to run all these this operator is running inside the OpenShift image registry namespace. So we will discuss about the operator later, but right now image registry operator is available. Now what else we have to do in the same config? The management state is right now removed. We have to set it to managed. Management state is removed. Set it to managed. And what else? Then configure the storage for the image registry in non-production cluster. Okay, so we change this. So here uh, it is for non-production mean you can use the empty directory as a storage. Right now what I did here, I define here as a claim. But if you don't want to use any storage class, or you are just testing this OpenShift cluster, so you can simply use the empty directory. So you know what is the empty directory volume. So this is will be available on the worker node wherever this image registry pod will run. But we have to uh, follow the proper storage class connectivity. Now enter the following command to set the image registry storage as a block storage type patch registry, so that it use the recreate rollout strategy and run with only one replica. So you can directly modify in this config but I modified, or you can also apply a patch that will update this config. So it is patched, and now if I show you what is patched, here you can see the rollout strategy is defined and replica are defined to 1. Okay, so in fact this uh, so this is a kind of configuration for the cluster. This resource is not in Kubernetes, but this resource is specially designed in Red Hat OpenShift for the configuration of image registry. So now we patch it. We did 3 changes. We changed this mem state. We define the storage class, and we make this patch. Next, we have to create this PVC. So I will create, I need to first of all image registry PVC. I will define, so I can say image. So persistent image registry storage, I use PVC. And in which namespace? OpenShift image registry. And read write ones mean only this worker node, only one worker node can use this storage at once. But if you want to make multiple replicas, so then maybe your registry will span across multiple worker node. In that case, you will set this read write many. But if you are only running one replica, then it's good. And 100 GB storage. And storage class definition is not given here. So the storage class definition we can use from the Helm. I use I just want to take the example of the template. So here, yeah, under the specs, we have to define this storage class. So NFS SC, OC get SC. So we have this storage class. Okay, let me now apply this. C create -f OC get PVC in, and this is a test claim. Let me just remove this. This is just a test one. Sorry, delete PVC. Okay, it is deleted. Now in this namespace, this persistent volume claim is created. Okay, Next, we applied this, and here this documentation is recommending that if you leave this claim value empty, it will automatically try to create some image registry, the persistent volume claim. But we defined our own, so we don't need to make this automatically. Okay, now the next step is about the OpenShift Data Foundation. If you are using, then we can use this method to configure our image registry. Similarly, uh, the OpenShift Data Foundation is a type of, you can say, the storage class uh, of OpenShift. So, but we are just concerned about the storage, and we attach with our NFS-based storage. Now, uh, the everything is done. Now, if I look into this namespace, now I should be able to see the this part. You can see now this pod is up. Previously it was down. So now image registry pod is up after this configuration. It's mean, and it is running, it's mean this pod is able to successfully access the persistent volume claim. Okay, so this part is done. Uh, Now image registry is successfully connected with the persistent volume claim. The pod is up. Now we have to create a route to access this image registry from outside the cluster. What is route? Actually, we did the exercise of ingress controller, and we define the ingress rules to expose any application on port 80 and 443 outside the cluster. So in the OpenShift, the ingress controller is by default running, and we don't need to configure it. The a custom resource definition is created by OpenShift. Let me show you OC API resources route routes. So this custom resource definition is created, and we can create this resource that will automatically add an ingress rule. So in Kubernetes, what we did, we create the ingress resource, and I believe ingress is also here. Yeah, ingress resource is also there, but we don't need to play with this ingress. If we are creating a separate ingress controller in parallel to OpenShift built in, then we can directly create the ingress rule. But we just have to create the route that will automatically create the uh, ingress rule. Okay, so our image registry was not up, that's why the route was also not up. Now, in this namespace, whatever we use for the image registry here, in this namespace, SVC. So before the configuration of image registry pod, this cluster IP you will not be able to see. Only this cluster IP is there. So now you know the image registry is running on port 5000. So it is up. And this cluster IP is also up in parallel to this pod that is written in the documentation. So if these both elements are up and running and this route, this service is created, now we can attach the route in front of this service. So you know, when we create the ingress rule, so ingress basically use the service. So similarly, route is using the service. So route and ingress, you can say both are same things. So to create the route, I will use the command oc create route, and I will explain you the types of ingress rules route that we can create. OC create route hyphen hyphen help. So we can create three types of route. Edge, create a route that use edge TLS termination. Mean you remember we in OpenShift ingress we define our own SSL certificate or at ingress controller level, and the application was not using any SSL certificate. So, but end user was able to access the application by using HTTPS. So that is known as edge. So it's mean the SSL certificate will be offloaded on at ingress controller level. Second is pass through. Create a route that use pass through TLS termination. Mean don't use the SSL certificate at uh, ingress level. Mean ingress reverse proxy whatever they used, and straightforward land the traffic for TLS to the pod, and in this case the your pod should be configured with SSL certificate. And re-encrypt is a combination of these both. Mean re-encrypt will offload the SSL at ingress controller level, mean reverse proxy level, as well as to to the application. In this case, your application should also be running on SSL certificate. So in this case, your application is secure till ingress controller level. After that, it is HTTP based traffic that is not secure within the cluster. In this case, it is secure end to end because end to end SSL is terminated to the pod. And in this case, you can define your own type of SSL on ingress, and then the traffic is rerouted again with the new SSL certificate that is available inside the pod. So, which type of route I will use? So here we will use a re-encrypt. Why? Because this pod that is created, uh, the pod that I showed you, just a minute. Yeah, this one. This pod is running on port 5000, and this pod having its own SSL certificate by default. So that's why I will use reencrypt. But if you are running some application that is straightforward using HTTP, then you can use Edge. So now OC create route type reencrypt. Then which service this route will use? Service will use this one image registry. Then which URL you want to use to terminate your image registry. So I can say host name is equal to, for example, registry dot any domain name I can use. So what I am going to use here, I am going to use a domain that I have registered on the internet, and I generated the SSL certificate, especially the signed certificate for this image registry. If you are using self-signed certificate, then you can get the issues with the image registry. So it's recommended to use the signed certificate so that your whole image push and pull process throughout the cluster and by the end user, by the DevOps engineer, will be very simple. They will not get any issue. So I generate an SSL certificate online by using Let's Encrypt, because I have this domain with this child domain name registry.itpspro.com. Now I also have to provide the certificates with cert hyphen cert is equal to and the path of the certificate, and I cannot browse this path here, and then I will also provide hyphen key is equal to the path of the key, and then the namespace where I want to create this resource. So my service is inside this namespace. I will create this here. Okay, so I'm just going to do just control C. This command is not completed. So here I have registry SSL, and here I generated these. This is a private key of the this SSL certificate, and this is the public key. So I will recall this same command certificate, and the certificate is full chain pem, private key pem, and in namespace this one. Okay, it's created. So OC get route in this namespace. So this route is created. Okay, the name of the route is same like whatever service I used, and this URL will be terminated. If I describe this, image registry, so here you can see the complete detail of this route, and it will use this certificate to terminate it. Now what I did on my machine, I make an entry in my host file, or you can make an entry in the DNS so that I can access the registry from my machine. So I point this to this load balancer, this interface, because my machine is this one. So this will hit to this IP to access the registry, and then it will be landed to by using the ingress controller to inside the cluster on port 80 and 443. So I can validate registry ITPS Pro. So this will show you a blank page, and you can see it is a HTTPS, and you can validate this with /v2. So if you look this message, it's mean your registry is up and you can access this from outside the cluster. Okay, and if I show you this certificate, so this certificate you can see it's generated by Let's Encrypt, and its expiry time is after 3 months. Okay, so till now we successfully set up our registry, and we create the route, and route is reachable by a special URL, and that special URL is using a special HTTPS certificate. If you are not using, by creating this route, this cert and key, then this route will be created, but when you will access this, it will use the default SSL certificate created by the self-signed SSL certificate created by the OpenShift installer, and that will give you an certificate exception, and you need to add it. But that will not work when you will push the image from the command line. So that's why I use the signed certificate. Okay, so our image registry is now working fine and good. But how can I validate the image registry? How can I push the image, and how can I pull the image? So for that reason, we have to make an understanding of OpenShift users concepts, how we can create the users in the OpenShift, and then we will use those users to log in into our registry, same like we are using the Docker Hub registry to push the image in the private registry. So same method we will use, but we must have to create some users. And those users we will create in the next video, and those users will be used to push and pull the images.